Hey guys, this is Miss Mitchell. I'm going to be walking you through your 9 weeks exam study guide. I am in the middle of my planning period, which is lunch, so don't be alarmed if you hear some announcements during this video, okay? I'll pause during them, but there will be releasing lunches, so you'll probably hear that throughout the video. Let me go ahead and get my pen pulled up, and then we'll get started. Alright, so the first thing that it asks us is to find the slope and y-intercept for each relation and write the equation. Alright, the two formulas that you guys need to have memorized, please make sure whatever you have to do to remember these formulas. So our slope-intercept form is y equals mx plus b, and our slope formula is m equals y2 minus y1 over x2 minus x1, all right? And hopefully you remember that m is slope and b is our y-intercept, okay, the y value of the y-intercept. So the first thing that we need to do to find our slope is, to write our equation is to find our slope. With two ordered pairs, we can do so by using our slope formula. So we'll have 12 minus 5 over 3 minus negative 4. This is going to give us 7 over 7, I believe. 12 minus 5. Yep. And that's going to reduce to 1, okay? So I'm going to write up here that m equals 1. And then we've got our m, but now we need our b, right? So we've got this part, but we don't have b. So we need to find b, and we'll do so using this formula. And you can use either ordered pair here. I'm going to use 3 and 12. So we've got x and y, and we're just going to plug in what we've got. So y is 12. M is 1 times x is 3. And we don't have b because that's what we're solving for, so we solve for b. All right, and then we have 12 equals 3 plus b. We want to get b alone, so we're going to subtract 3 from both sides. And then we get 9, so 9 equals b. So now we know what b equals and we know what m equals. Neither one of these are the answers though, okay? So don't stop there. We still need to finish what it said, which was to write the equation. So we'll plug in what we know, and we've got m of 1, b of 9. So we'll have y equals, that's really thick, hold on. So we will have y equals x, you could put 1x, but there's no need to put a 1 there, plus 9. Okay, so this is the answer. All right, then we've got to find the slope first of this table. So we subtract up, so 18 minus 13 is 5, 13 minus 8, 5, 8 minus 3, 5, so on and so forth. Double check yourself, but just for the purpose of this video, I'm kind of, bouncing around. All right, and then 1 minus 0 is 1, and we can confirm that it's going to be 1 the whole way up. So this side is 1. And if you remember, we write our slope as rise over run. And for rise, we're looking at that y-intercept, so we have y over x. So our slope is going to be y over x, which is 5 over 1, which is just 5. Okay, so this is m. And then our y-intercept is what we need for b. And when we're looking at a table, we'll find our y-intercept by the x value of 0. So we have an x value of 0 here. So 13 is our y-intercept. So we'll put b equals 13. And then we're ready to write our equation. So we'll have y equals slope of 5, 5x, b of 13 plus 13. And that's your answer. Number 2, which value of x is excluded from the domain? This is asking us which value of x is not going to work. Which one is going to make this undefined? And we know that an undefined slope has a 0 on the bottom. So what are we going to put in for x to make this denominator 0? Well, the opposite of 9 is negative 9. So that's going to cancel out that positive 9, right? And then we'll have a 0, and it'll be undefined. All right, then it says, what is the slope and y-intercept of the line y equals negative 4x plus 6? Well, if you've got this formula memorized up here, then you'll know that m is your slope, b is your y-intercept. So our slope is going to be negative 4. And notice here it asks for y-intercept, not b. Okay, so that means we need the full ordered pair. it's going to be 0, 6. Remember, y-intercepts always have an x value of 0. All right, does this table represent a function? Well, we need to check our x's. Do we have any x's repeating? No. And remember, x is what we care about repeating. We don't care if we've got the same y values, but we don't have any x's repeating, so yes, this is a function. And it's no x's repeat. Now, if we had some x's repeat, like if we had -3, 4, we would have the same x value with different y values, so this would not be a function. But if we had -3 and 3, well, that was already on here once, so this is not changing anything. This would still be a function, okay? We only care if the x's repeat and have a different y value. All right, now we need to answer a few questions about this graph. So it says, where are the x and y intercepts? Well, we're crossing, remember, this is our x-axis, this is our y-axis, so we're crossing here, here, and here. So make sure you label those intercepts. So our x-intercepts, and we write these as ordered pairs. Our x-intercepts are going to be -2 and 0, and 4 and 0. Remember, x-intercepts have a y value of 0. Then our y-intercept is all the way down here, and it has a x value of 0, don't forget. So our ordered pair here is 0, -8, -8. All right, our vertex, right? This is the highest or lowest point. Highest or lowest point. So we don't have a highest, but we have a lowest, right? It's going to be right here. And vertex is also written as an ordered pair. And our ordered pair here is 1, -9. And if we have a vertex, we also have a max or a min. In this case, it's the lowest point, so this is a minimum. So this is our minimum. Make sure you label if it's a max or min. So this is min, and we write this in terms of y. So our minimum here is y equals -9. All right, and if you notice, it's the same, it's the y value of our vertex. Okay? And then it says, does the graph have symmetry? That means, can we fold this? I did not mean to do that. Can we fold this in half somewhere and have it line up perfectly? Well, our vertex is right here, which means this is the middle point, right? Can we fold it in half right here and have the same image on both sides? Yes, right? We can fold it in half right here. And symmetry is written in terms of x. So we'll have x equals, and this x value right here is +1, so we have x equals 1. And if you notice, this is the x value of our vertex. So if you're ever unsure about your vertex, or if you're max or min in symmetry, they should all balance out, okay? Transformations. So we're looking at the parent function y equals x, which we know is really y equals 1x plus 0. We know that we look at slope, which is 1 rm, for reflections and steepness. And then we look at b for vertical shifts. All right, so here we go from 1 to -3. First things we need to notice is that slope is now negative. This is a reflection. If your slope changes sign, you have a reflection. Then we go from 1 to 3. Right, well, 3 is greater than 1, so this is going to be 3 times steeper. I'm just abbreviating for the sake of having enough room. And then we go from 0 to -2. This is our y, so if we go from 0 to -2, obviously we're a vertical shift down 2. Okay, now we've got y equals 1/3 x plus 4. First thing we notice is our slope goes from 1 to 1/3. This is smaller than 1, so we're going to be 1/3 times flatter. Remember, if it's smaller than your original slope, we're flatter. If it's greater than, we're steeper. Then our 0 turns into a 4, +4, so we are a vertical shift up 4. Last one, we've got y equals x plus 6. Our x doesn't change, but our b goes from 0 to 6, which means we have a vertical shift up 6. Let me move this out of the way. All right, so now we need to write an equation of a line with the given information. Well, if we remember, just like we talked about, the things that we need to remember for this are those formulas. Like I said, if you remember anything, please remember these. So we have y equals mx plus b, and we have m equals y2 minus y1 over x2 minus x1. That's what we're going to be using to solve these. So here we're already given our slope, but we don't have a b, so we need to solve for b using this formula right here. So this is our x and our y, so we have 7 equals negative 2 times 3 plus b, which makes it 7 equals negative 6 plus b. We're going to add 6 to both sides, and we get b equals 13. So now we know b, we know m, we can write our equation. We'll have y equals negative 2x plus 13. So this is your answer. Right now we have the line that passes through the points, negative 4, negative 2, and 3, 5. Look past all the wording and let's just look at the fact that it gave us 2 ordered pairs, okay? So that means we don't have a slope, means we need to find it. So we'd have 5 minus negative 2 over 3 minus negative 4. This is going to give us 7 over 7, which is 1. So we've got m equals 1. And then now we need to find b. So let's use 3 and 5 because it's easier without negatives. So we would have 5 equals 1 times 3 plus b. 5 equals 3 plus b minus 3. And b equals 2. So now we have our slope and we have our b. We can write our equation. And it's going to be y equals x plus 2. Remember, there's no need to write a 1. Okay, now we've got a slope of negative 3 and goes through the origin. All right, well, we've got our slope. This is our m. And our origin is an ordered pair. And if we remember, that ordered pair is 0, 0. Well, if you remember that a y-intercept is always going to have an x value of 0, which we do here. So this is our y-intercept. We don't have to solve for b. We know that our b is 0. Okay? So with that being said, we can go ahead and write our equation. It's going to be y equals negative 3x. And it would be plus 0, which there's no need to write. So our answer is just y equals negative 3x. Okay? And then d is a slope of 1/2 and goes through the point 2, negative 3. All right, so we're given our slope. This is m. And we're given a point, so we need to find b. So to find b, we would have negative 3 equals 1/2 times 2 plus b. This is negative 3 equals 1 plus b. And then we subtract 1. This is negative 4 equals b. So now we know our m is 1/2, our b is negative 4, and we're ready to write our equation. And it's going to be y equals 1/2 x, sorry, not plus, minus 4. Okay, make sure you watch your signs. All right, so always remember that the final equation is your answer, not what you're doing in between. All right, now it wants us to determine if the graph is discrete or continuous and if it's a function, and then state the domain and range. So we remember that a discrete graph is going to be random points. A continuous is a continuous line, right? So if it's continuous, we state the domain and range in algebraic notation. And if it is discrete, we just list all of our x and y values for each point on the graph, okay? So number 1, discrete or continuous. This is a line, so it is continuous. Function, does it pass the vertical line test? Yes. Right now we need to look at domain. If we remember, domain is our x and range is our y. So for domain, we need to look at our x. So our first x is going to be negative 4. Our last x is positive 4. So we're going to have negative 4. Remember, we're always going to use the less than symbol. And in this case, we have a closed circle, so it's less than or equal to x. Again, a closed circle, so less than or equal to positive 4. All right, and then for our range, our first y value is negative 5, and our last y value is positive 1. So we have negative 5, closed circle, less than or equal to y, closed circle, less than or equal to 1. All right, B, at another line, this is again continuous. Is it a function? Does it pass the vertical line test? Yes. All right, domain. Notice we've got 2 arrows going off of the graph here. So our first x is going to be infinity. Our last x is going to be infinity. And if we have infinity for both, it means all real numbers. So x equals all real numbers. All right, and then our range is our y. Remember, for range, we look bottom to top. So our first y value is negative 5, and our last y value is infinity. So I'm going to write it down here just the way it looks. We've got negative 5. Remember, if it's on a line, it's essentially a closed circle, so it's going to be less than or equal to y. If it's infinity, we just use less than infinity. And we know that we can't include infinities in our algebraic notation. So that leaves negative 5 less than or equal to y. Well, we want y to be first, so we're just going to flip it. So we'll have y is now greater than or equal to negative 5. Okay. C. We've just got a bunch of different points on the graph, so this is a discrete graph. Is it a function? Does it pass the vertical line test? No, because we have these 2 points right here. Right, and then for our domain, we would notice that this is negative 5, negative 7. This is negative 2, negative 3. Then we've got negative 2, positive 3, 0, 8. And then we've got, what is this one? 3, 5. And this one is going to be 5, 5. And then we've got 0, 5. So we list all of our x's in the domain, and we do this in order from least to greatest. So we're going to have negative 5, negative 2, 0, 3, 5, and 6. I wrote this one as 0, 5, and 6. That's where I got that 6 from down here. So we're just writing all of those. I just realized I totally messed that one up. This is 6, 0. My bad, guys. Kind of rushing through this, and obviously I shouldn't be. But, so we've got negative 5, negative 2. We only need to write it once. 0, 3, 5, and 6. Okay? And then our range is going to be all of our y values, and we write our range in order from least to greatest as well. So we start at the bottom and go to the top. So we're going to have, geez, I'm messing up all kinds of bad. Negative 7, right? And then negative 3, okay, 0, positive 3, 5 we've got twice, but we only have to write it once, and then 8. So when it's a discrete graph, we just list all of the x and y values. All right, we're going to use this graph to answer 9 and 10. So we need to find the slope and y-intercept. So let's do that first. Notice, first of all, that this graph is decreasing, so we're going to be negative. So let's find 2 points. And we're going to go down 1 and over 3. So our slope is negative 1 over 3. Our y-intercept, notice it's not asking for b, it's asking for our y-intercept. It's positive 2, so we've got 0, 2. And now we need to write our equation, and it's going to be just our slope and our y-intercept put into that slope-intercept form. Y equals negative 1/3 x plus 2. Okay, let's keep going. All right, so for each parent function, we need to identify the function and the shape of the graph. So we have y equals the square root of x. So this one's pretty obvious. It's a square root function. Y equals x squared. If you've got these exponents, it's a quadratic. Y equals the absolute value of x. This was another pretty obvious one. This is absolute value. And then we have y equals x. Hopefully you remember from all of our transformations, this is our parent function that we're comparing all of our other functions to. So this one is linear because we've been talking about linear functions and whatnot. So now let's talk about the shape. The shape of a square root graph looks like an R. The shape of a quadratic graph is a parabola or a U. The shape of an absolute value graph, remember value, it's V. Remember root, it's R. And then linear is going to be a line, right? So line, linear. Let me scroll down a little bit. All right, so it gives us the range of a function and wants us to find the domain. Well, if we remember correctly, the range is a y and the domain is our x. So when we are given the range, these are going to be outputs. Okay, so that means we need to plug them in on the outside. So I'm just going to do 31, and then I'll list all the other ones. But we'd have 31 equals 2x plus 9. We would subtract 9 from both sides, and then we get, oh, I don't know why I did that. Moving it over here, 22 equals 2x. We need to get x alone, so we divide by 2, and x equals 11. And you would do the same thing for all of these other numbers, but I'm out of room, so I'm just going to show you the 31. But then when you list your domain, make sure you label it domain, and once again use brackets and write it in order from least to greatest. So once you work all of these out, you should have -4, -1, 3, 7, and 11. Okay? Now we're given the domain of a function and we need to find the range. So the domain is at x, so we need to find our y. And it says that our domain is whole numbers less than 3. Well, whole numbers start with 0 and anything less than 3, so 1 and 2. 0, 1, and 2, that is our domain. So for finding the range, we are given x, so we're just going to plug in for x, right? So we have, I'm just going to do 2, and then you guys can do 0 and 1 on your own. So we've got 4 times 2 plus 5. 4 times 2 is 8 plus 5. It's going to be 13. And then once you work out 1 and 0, you'll be ready to list your range. Make sure you include brackets, and again, in order from least to greatest. And you'll have 5, 9, and 13. Okay. All right, now back to chapter 1. We need to solve the equation for x. So hopefully you guys remember how to do this. On a, the first thing we need to do is distribute that 3 out. So we'll have 3x minus 12 equals -39. Well, we're trying to get x alone, so we're going to start by adding 12 to both sides. We'll get 3x equals -27. Divide by 3, divide by 3, and then x equals -9. Right? On B, we've got 8x minus 3 equals 3x plus 22. First thing we need to do is get these x's together. So we'll subtract 3x from both sides. We'll get 5x minus 3 equals 22. Okay, we want x alone, so we'll add 3 to the other side. 5x equals 25. Then we're going to divide by 5. And then we get x equals 5. All right, x plus 5 over 7. Well, if we remember correctly, x plus 5 is a group. So we don't want to touch that 5 yet. So we're going to multiply each side by 7. And then we get x plus 5 equals 84. All right, we need to get rid of this 5. So subtract 5 on both sides. And then we get x equals 79. Okay, and then we've got x over 3 minus 5 equals 9. Well, the first thing that we want to do is get rid of this 5, so we'll add 5 to both sides. Then we've got x over 3 equals 14. Then we want to get x alone, so we're going to multiply by 3 on both sides. And then you get your answer, x equals 42. All right, let's keep going. All right, 14, use your graphs to answer the question. So what we're doing here is finding our ordered pairs, okay? So if we're given, remember if it's in parentheses, it's an input, and if it's outside of the parentheses, it's an output. So inputs are x's, so we've got all of these x's, and these are y's. So first things first, g of 2 is x equals 2, so here is x equals 2, and here is our point. That point is 2, 1. G of negative 2, x equals negative 2 here. This is our point. So we've got negative 2, negative 7. G of 4, x equals 4 here. Come down, make sure you are careful with this one, but it's negative 7, so not negative 4, I'm sorry, 4, negative 7. Right, now we've got to switch to the y values. Y equals negative 7. Well, this is negative 7, and we've already got 2 points there, so we'll just bring those down. We've got negative 2, negative 7, and we've got 4, negative 7. Then we've got g of x equals 1. Where does y equal 1? Right here. We've already got 1 point, but as you can see, there is a second point. Make sure you're not writing your y's as your first spot. Remember that your ordered pairs are always going to be x, y. So we've got negative 4, positive 1, and 2, 1. Pause for interruption.
Grab and go, second lunch.
All right, so now we're on to 15. This is again continuing with the inputs and outputs. Don't worry about what this is saying, just worry about what it's telling you to find. So find all of these is what we're looking for. Notice this one tries to trick you up by switching the order, but we're still looking at what we're finding, okay? So if it's in parentheses, it's our input. So this is an input. This is outside the parentheses. It's an output, input, output, and input. So this means we're plugging in for x. This means we're plugging in for f of x, okay? So we've got 15 minus negative 3. And that gives us, make sure you write the variable that it's equal to. And in this case, we're solving for y. You could write y or f of x. Y equals 18. Right? Then b, this is an output. So we're putting 5 on the outside. So 5 equals negative 3x minus 7. We're going to add 7 to both sides, and we'll get 12 equals negative 3x. Then we divide both sides by negative 3. I'm running out of room. But once you do that, you get x equals negative 4. Okay? C, we've got another input, negative 10. So plug in for x. We've got 8 over 10 minus 4. This is going to equal negative 10. 8 over negative 14. Negative 10 minus 4 is negative 14. And then we can simplify this, and we'll get negative 4 over 7. Remember, it doesn't matter where you put the negative sign. So x equals, not x. It's been a long day, guys. Y equals negative 4 over 7. All right, last one before it flips up on us. We've got an output, so once again, we'll have to put that on the outside. 23 equals 4x minus 5. We're going to add 5 to both sides. We'll get 28. 28 equals 4x. Divide by 4. And our answer is x equals 7. Okay, and then F, like I said, tries to trip you up because it flips the way that it's written, but it's no different. This is f of negative 3, which we said was an input, so let's plug in for x. Watch yourself here with the negatives and the absolute value. Okay, so we've got negative absolute value sign 3 minus x minus negative 3. Close the absolute value sign. All right, well, our inside is going to be positive 6 because it's in those absolute value bars. But then we've got this negative on the outside, so it becomes negative again. So we have y equals negative 6. All right, now we need to look at these and determine if they're even, odd, or neither. Well, if we're looking at pictures, remember if it looks the same upside down, it's odd. Well, this one would look the same upside down, right? So this one's odd. Let's go ahead and look at the other picture. If it can fold over the y-axis, it's even. Well, this one has symmetry down the y-axis, so this one is even. Now let's look at our functions, right? So we are looking at exponents and constants. So we have x cubed, that's odd. Remember there's an imaginary 1 here, so that's also odd. And we have a constant. Well, we can't have odds and constants together, so this one is neither. If it were just these, if we took away this minus 1, it would be odd, but because of that constant, it's neither. We've got x to the 4th power, this is even, and we have a constant. Well, remember we can have constants in our even function, so this one is even. All right, now these are pretty basic, but we just need to make sure that you guys can do this. So literally all you have to do is type these into a calculator. So A is going to be 9.4, B, negative 28. Remember, plus negative is minus. C is 1. D is negative 15. And E is 46. Okay, now we need to simplify these expressions. And it says tip combine like terms. So let's highlight our like terms. We have negative 2y squared and 8y squared. So that's going to give us 6y squared. Then we've got 3x and minus x. So this is going to be plus 2x. And then we don't have any like terms with 7, so just minus 7. Okay, then we've got b. So let's start with our exponents. We've got x squared y and 3x squared y. So remember there's an imaginary 1 here. So we're going to have 4x squared y. Then we've got 2x, nothing else with no other x like terms there, so plus 2x. Then we've got negative 5 and positive 2. It's going to be negative 3, so minus 3. All right, we're almost done. All right, 19, we're using the distributive property. So 4 distributed is going to be negative 8w. 4 times 6 is going to be 24, so negative 8w plus 24. And then on this one, we're just distributing that negative out. So we'll have negative 9p, negative times negative is going to give us plus 7. Okay, number 20, we are just simplifying once again. So negative 2 plus 3, and we're distributing that 3 out. So we'll have 15. 1 squared is 1, so 3 times negative 1 is negative 3. And this is going to give us 10. Okay, all right, 32 divided by 7 minus 3 squared. Well, remember, let me get my pen back up here. It's telling us to use PEMDAS. One second, we have an interruption.
Third lunch, Orange Day, dine in at this time.
Okay, so we have 7 minus 3, parentheses is first, so we have 4 squared. Just bringing everything down now. So we have 4 squared, if we remember, hopefully we do. 4 squared is 16, so we have 32 divided by 16. And 32 divided by 16 is 2, okay? So the answer here is 2. All right, last set of problems, we need to identify the classifications of real numbers. So 1.68 is a rational number, but it's not going to be anything else. We lose anything after decimals, right after rational. 22 is going to be rational, an integer, whole, and natural. So know that we can count with 22, so it's a natural number, making it everything else above it. Square root of 49 over 25, this needs to be simplified. So square root of 49 is 7. Square root of 25 is 5. So now we have 7 over 5. This is going to be a rational number, and that's it. Then we've got 0. This is going to be rational, an integer, and whole. Remember, whole numbers start with 0, but at natural numbers, we drop our 0, right? So just rational, integer, and whole. One second. Okay, guess they didn't have anything to say, but I thought they did. And then E, we've got this long decimal, so we've got irrational, and that's it. All right, Good luck on your 9 weeks test, guys. Your teachers are here for you if you have any questions that you may need to ask before the test tomorrow. Don't forget your study guide is due tonight at 9, and good luck.